Anybody else? Anybody else? No, I know there's some of you here that I forgot about that said you were going to do one. All right. Well, while we're finishing the setup here, let's give a shout out to our wonderful sponsors. Wait, hold on. I can't stray from the camera. So, yeah, we got Lamppost Group, Carbon 5, EPB, CoLab, Society of Work, and University of Tennessee, Chattanooga, College of Engineering and Computer Science. All right, everybody give them a round of applause. Give them a round of applause. They've got this every week that you eat is because of these generous folks right here. So, yeah. I just really like this green laser. Yeah, it's nice. All right. Yeah, that's great. Well, hey, I can do this all day, much to everyone's chagrin. Let's see. Next week. Does anybody know what the talk next week is? What's that? Yeah, lasers next week, me. No, of course, you. Reed. Yeah, programming languages where they don't belong. That's right. Reed Spool is going to be coming at you with programming languages where they don't belong. So it's going to be an interesting talk, and you should come out for that. Thank you all for volunteering your time. We're booked up now through July, and so that's great. I'm out of panic mode. And if you want to come through and give a talk in August, come get at me. Let's talk about that. Let's make it happen. What do you think? That'll be fun. We about ready to rock and roll here? Maybe? Maybe. Mic one.
Yeah.
Why don't, you can connect to the Wi-Fi here. Floor 5 gig.
Yeah, I can do that.
Up to you.
If it's better.
Up to you.
Okay.
If this is reliable, then don't worry about it.
I'll just leave it on then. All right.
Everybody give it up for Matt. Round of applause for Matt.
Nice to meet y'all. So, my name is Matt Ward, and my business is to maximize the use and the effectiveness of biofeedback. And so what I'm interested in doing with biofeedback is taking it more in the direction of what I consider to be a simulation of conditioning. And so, these two statements can be, can summarize the basic approach here. But there's 3 outcomes so far to biofeedback. The first one is to intervene in a stressful situation. So a person learns a rote method of responding to stress arousal, and then they carry out a behavior consciously to counteract the effect of that stressor. If carried into the long term, you can create a long-term trend with exercise to set the stage within the body to cope with stressors more effectively. But this is, again, sort of limited because it's not creating a definite fundamental change in the order of the nervous system. The third is what I'm interested in. It's in staging the opportunity for the nervous system to revise its associations with stress response so that cues in the environment don't arouse it subconsciously, and therefore you never have to get to a conscious state of stressful arousal. So feedback, as usual so far, is operant and the media is hot. Oftentimes it's a direct feedback, so a person has to consciously manipulate some sort of exterior cue to reach an internal experience of perception, and hopefully the nervous system will change to accommodate that change. Even when it's not operant, even a passive feedback mechanism where instead of, for example, eyes closed, you're listening to auditory cues, and yet you're still relaxed and very quiet, the media is still hot. So the media itself is creating an interruption to the very process that it's seeking to engender. So if you want to cool the media down, number one, there is a branch of cybernetics called perceptual control theory. And it's concerned with the nature of behavior as it relates to perception. In fact, its tenet is behavior is the control of perception. By simply altering the way that the feedback is received through altering the media, you can switch from an operant positive feedback type to a negative feedback. Everything is shifted toward the more subtle. You're looking to gain a more subtle experience of the body itself, and therefore the sensational experience is the emphasis. Every other feedback mechanism is designed so that through negative feedback, only by carrying out the desired behavior are all feedback components eliminated. So you're being funneled into a behavior rather than necessarily being trained into a behavior. So if you're going to simulate the emergence, one of the things we need to know is that this is all based around the freeze discharge, which is the mammalian process within the nervous system of removing associations between traumatic instances and future stress responses. One of the aspects of freeze discharge that we're most concerned with is a metabolic updraft. You're looking to create balance in the nervous system and also the metabolic system so that you can push that balance to its limit without surpassing it, creating an aversion state. Aversion is just like it sounds, where you don't necessarily want to continue because you have a self-protective sort of nature to the order of one's nervous system. So you have to direct that energy by directing attention, and then allow the system to express itself in such a way that doesn't interrupt the process that you're carrying out. Pardon me, this is a little bit word salady in my head, but I'll get there. So we're pushing the envelope of maximizing the use of biofeedback. One thing that we can approach is working with trauma recovery, and in doing so, the prospect of actually pushing the boundaries of human limitation also are present. We can recover from physical and mental exhaustion more readily, and this lends itself to all sorts of high performance and other kinds of training. We can create artful experiences where people can interact and approach things like social phobias and anxiety by creating a mutually supportive and challenging scenario where people can interact in a state where their nervous systems are coming more to a cohesive trend. And then in the future would look at the potential of adapting life support systems. So if we're establishing the deepest sense of balance that a body can express, then the potential to maximize the efficiency of a system that looks to support that organism within an environment can be adjusted as well and made more succinct. So the first embodiment that I'm working on now, cell phone technology is more than enough. I just need a basic sensor, and the vocal training and music performance technology is kind of where this is all centered, a mode of social bonding. The second generation could be anything from light sources to sublimating the cues to anything that involves arousal and stimulation. In the far future, you could create an entire environment of feedback and set the stage so that a person can experience as little interference to what's already established as a deep state of relaxation, but also carry them deeper and deeper into the discharge of associations with stress response. And so at this point, I don't necessarily have a laboratory established, but I'm working with someone in Huntsville, Alabama to embody these technologies. And so we've just set upon this course. Perceptual Recursion is the YouTube channel that I'm using to present a webinar series to more or less be the first step in a crowdsourcing effort. And so my name is Matt Ward again, and I appreciate your time, and thank you very much for hearing me out.
All right, a couple of announcements. Over here. I'll pass it off to Reed here.
Hi, my name is Noel Weichbrodt. I'm a software engineer with OpenTable. I, along with Neil Mean, host a new chapter of Papers We Love. Papers We Love is a monthly meetup devoted to discussing seminal papers, academic papers in computer science. You can think about it as kind of like a graduate school seminar that we all contribute towards. So one presenter each month presents on one paper, one or two papers, and then we have a little discussion afterwards. So if you've been thinking, man, I wish I could go back to school, but I actually don't want to go back to school. I just want to sit in on a cool grad school class for one night a week. This might be the place for you. If you're thinking, man, I wish I could read more Leslie Laporte papers or Eric Dykstra papers. I know many of you fall asleep at night thinking about that. So this is going to be a great place for you. Our meeting on Tuesday, this coming Tuesday, is going to be about subtyping, subclassing, and the trouble with object-oriented programming. So it's going to be somewhat controversial if you're into kind of dry academic disputes where we all accuse each other of not following mathematics very well. But there's going to be slides and GIFs and like all kinds of things to make this like understandable. Because I don't understand when Oleg Kirchhoff, who's at the Naval Academy Research, blah blah blah, in the United States, like writes these things. I don't understand half of what he writes. So the intent is to bring this down to a digestible, understandable level so you can understand what these big papers in computer science mean to you. So that's next Tuesday. We're on the meetup. If you go to paperswelove.org, we're on there. You can RSVP. We give you food. Thanks.
All right. Thank you, Noel. And now we've got Tim. Everybody get over for Tim.
Hey everybody, I just wanted to make a quick announcement about our Innovation Happy Hour that we do once a month. Our next one is going to be next Wednesday. It's a special event. We got somebody from our Geek Tank team built an app for networking, intentional networking. You can go on and download it. It's called Mixtros, but we'll be networking with the app. And we have Moorhead Kane scholars that has been in to Chattanooga from North Carolina. They're going to be speaking about their experience here in Chattanooga. And we have Odd Story Brewing, which is a brewing company, a startup brewing company. They're going to be here giving beer samples for everybody that is of age. And we also got another startup, Super Juices, is going to be giving out samples of freshly pressed vegetable and fruit juice. So it's our fourth happy hour, and we got usually about 90 people come, but this is one you don't want to miss. So just letting everybody know, it's be Wednesday, July 6th from 5 p.m. to 7 p.m.
All right, so one more thing is that tonight, how many of you went to Startup Week last year? Went to some Startup Week events last year? Yeah, so planning is happening, and if you want to host an event, or you've got event space, or you're just interested in what's going on and kind of like what's happening with it and want to have a voice, you should come here tonight, this floor. I think it's 5:30, and it's kind of just a community organizing event just to make sure everybody gets out and everybody's heard and that kind of stuff. So come out, it'll be good. Yeah, we're going to try to host an event as CHADEV, so if you have any ideas about that, let me know. I'd love to hear them. Other than that, we got Lightning Talk speaker number 2, Jared. Everybody get up for Jared. Mic 3.
3, hello, there we go. Once again, my name is Jared Menard, and I'm going to be talking about how to scale Rails to 4,000 requests per minute. I don't even know if that's good or not, but it's better than what it was for our production web server, so it's kind of relative, I guess. And also, this is a story that started a week and a half ago and is going to end in a week and a half. And so I don't even know if this is going to work like I think it's going to work. So those are all my caveats. And talk to me in a week and a half to see if I still have a job and if this worked. So here's the story. One of our customers says, we're going to try to get 1 million people in the National Mall in the middle of July. And at some concert event thing, we're going to get them all to text this phone number, and it's part of this call to action thing. And so potentially, if all their marketing hype is accurate, we could get up to like 1 million text messages in like 10 minutes. So that's potentially disastrous. But really, since we make 1 penny for each of those texts, that's my first thought. And I was like, yes, this is going to be great. Think of all the pennies. Also, interesting fact, if I was to text our system 1 time per second for 8 hours, I would pay for my salary. So, little stat. And my second thought was this. Load. Exactly. So like, a slow loading GIF on fire is exactly what was going to happen to our current web server. So I enjoy working on performance. And my first thought was, all right, I need to gather some data. So I wrote a script that I called ddos_script.rb. And this is basically what it did. It started up 1,000 threads. Each thread made 100 web posts to my Twilio endpoint, and bad things happened. On a good day, a response is like half a second, ran a bunch of queries. Quick tidbit, a active record create takes about 20 milliseconds in my experience, so that all adds up pretty quick. Faye is a pub sub service that we use, and basically we DDoSed our own server with Faye notifications. Wasn't good. So first iteration, Mark 1 was like, all right, let's just throw it all in the Sidekick. Let's take those params and throw them into a Sidekick worker, and then return 200 OK, fingers crossed, hopefully this works. And my response time on my API endpoint got a lot better. It was like 10 milliseconds, and life seemed great for the first few seconds until like Sidekick filled up, and all that crappy code that I was still running in my controller, which was now moved to a service, was still being crappy and taking half a second to load, and filled up all my Sidekick workers, and caused more DDoS terribleness. And that is what happened with my first house that I built. It got blown down. I guess I already said that. So Mark 2 was, all right, instead of throwing it into Sidekick, I'm going to throw my params into Redis, and then I'm going to start one Sidekick worker to chunk through all those params one at a time and create messages from Redis. And this worked a little better, but it was still creating messages one at a time. And like I said, those active record creates take 20 milliseconds. And if I'm going to like somehow create 1 million texts in 10 minutes, that's not going to work. So that's what happened. So let's see. This is my current design that I've kind of come up with some help with some people here on the Chata Slack channel, and just thinking about this a lot. And so currently, I'm going to still throw everything in Redis, and that's been fast, and that's great. And I have 2 tiers of Sidekick workers. The first tier is just going to generate a large SQL insert statement up to 1,000 records and execute that. So I'm bypassing active record. I'm just using it to execute the query. I'm not inserting one at a time. I also added a flag called processed to my model, and default value is false. And so I'm bulk creating thousands of records in my database. I'm not wiring up associations. I'm not firing off Faye notifications. I'm not generating more Sidekick worker noise. I'm just throwing it into Redis, throwing it into MySQL, and then a secondary worker comes behind and slowly wires up associations, fires off Faye notifications, and will hopefully aggregate all those together. Eventually, I'm still working on this right now. So I'll send a lot less Faye notifications, run a lot less Sidekick worker jobs, and doing bulk creates and stuff like that. So I tested that, and I got about 4,000 requests per minute on our staging AWS instance. And so we can hopefully auto-scale that as needed. Still testing.
Oh,
to handle whatever load. But in real, really, there's probably gonna be like maybe 100,000 people, and maybe only like 10% of them text in. So it's only like 10,000 texts over 30 minutes, and that's fine. So there we go. So talk to me in a week or two and let me know to see how it went. Hopefully it went well. That's the end of my talk. Thank you. Guess I need to sign out.
Let's see if this works. No, it did not. Hold on a second, let me change the setting then. Thank you. I took the picture myself. Sierra Mountains. No, I didn't. I'm a liar. Kind of hoping that the announcements will be going on right now. We decided to pile them all. Thanks, Brett. Appreciate your. There she is. Not for the decimator. All right. You like it? Famous last words. We'll see. All right. Name's Tim Ojo. Don't have any useful information for you today. Just here to tell you why computer science is awesome. Don't pay attention. No, actually, do pay attention. But bear with me here. Computer science is awesome because we have the best inside jokes. For example, this. The 2 hard problems in computer science. Caching, naming, off by 1 errors. Or this. For Java. Or this. That is so true. We check out XKCD. I love it. Love the CL command. And I can't tell you how many times that happened to me as a junior programmer. That is so just like, I don't know what it does. It just works. Or this. Now that lastly there is hardcore. That's the true definition of hardcore. All right. Computer science is awesome because we find creative ways to find the fact that we messed up. For example, we can say, got page not found. Or this little baby crying over the page. Oh, I'm sorry, it'll be back soon. Don't worry about it. Oh, good old Uncle Bern, tell us like it is. He knows something about it. He did invent the internet. I can't think of a better way to pass time out if you get a 404 page. And we all know it's the junior developer's fault. So just blame him. No, it's not fair. It just isn't. It's sad. Computer science is awesome because we can take confusing acronyms, because acronyms are already confusing, and make them even more confusing. I give you recursive acronyms. GNU, which is GNU's not Unix, PHP, curl, RPM, I'm pretty sure most of us knew these. But then there's also herd, which is the granddaddy of them all, which is a mutually recursive acronym. Herd of Unix-based daemons, and herd of interfaces representing depth. By the way, that's real F# code. You can compile it, and no, it won't. It's not true. It won't run. I don't think so. Computer science is awesome because we tackle the really thorny debates like whether the curly brace should be on the next line or on that first line. That's just real thorny debates. By the way, clearly, next new line, everybody knows more white space is better. Tabs versus spaces, tabs, come on, there's a whole key there. 4 spaces versus 2 spaces, just hit the damn tab key and move on. Vim versus Emacs, neither. Python versus Ruby, Python is cute and furry and all, but everyone knows real computer science gets done in Python. Static versus dynamic, if you like slow code, you can go dynamic, it's okay. And is this really a contest? Seriously, I don't get this. Like, you can kill him in 2 seconds. All right, computer science is awesome because reality sucks, but don't worry, we fixed it. We invented these. You want to look really dorky? Or that? I guess that's like a trackpad at the back. You move that way or something. I don't know what you're doing with that. Or that, complete with alien woman with alien eyes. I have no idea what they're doing there. Or that's 3D printed. It's crazy. We fixed your reality. And I don't know what's going on with him. Also, we fix your things. So do you ever want to have scintillating conversation with your dogs while giving them dog treats? You can. It's a smart doggy food dispenser. Or a smart egg tray to tell you that you're out of eggs. That's a real thing, people. It's on Amazon. It's real. Or, I love this one, Belty, the smart belt, that loosens up when you've had a big meal. That's real. This is my favorite. I'm a father to a 2-year-old, and we all know that it's much harder to check a diaper than to just check Twitter when when your baby is going in diaper. So you just check your Twitter and it'll tweet you, hey, some stuff in there. It's awesome because we keep building sentient AI, even though we know how this movie ends. Come on, how many movies have we seen of Skynet and this guy who is clearly threatening? Actually, it turns out to be a good guy in the end, but still. And that guy, really, do we want to bring him to life? Please don't. Maybe not so bad after all. Also, computer science is awesome because you can make a difference, meaning lots of money, even if you look like this guy. Someone told him and said, look nice, Bill. That guy, I'm really afraid for that apple right now. Oh, this guy, that's your leader, nerds. That's him. But seriously, for the longest time, our classrooms and workplaces have looked like this. When we need to start working towards looking like this, and we need to start to extend an invitation and tear down the barriers and walls that make it harder for people of different races, genders, or even age groups to come and bask in the awesomeness that is computer science. So thank you very much.
Next up is Reed Spool. Mic 3. You want a clicker?
No, I'm good. Oh, that's not the thing. Do the thing. Yay, that's my name. Hi, everybody. This talk is going to be a preview of the longer version next week. So I'm just going to go real quick through this stuff. My name is Reed Spool. I do, you can't see the corner over there, independent software stuff, mostly on the web, front end, back end. I avoid the bits in the middle, though. Today, I'm going to talk about, I titled it for next week, Programming Languages Where They Don't Belong, or A Big Fish in a Little Pond, or a Turing-complete language appended rudely onto a URL. So this is the overview. I'm going to go real quick through this stuff. What's in a URL? what's at the end of a URL. Should we mess with it? Spoiler, yes. This whole thing is a spoiler for next week, so if you don't want any, just earmuffs. What kind of language should go there? What's concatenative mean? What's factor? And my URL programming language. All right, so what's in a URL? Start with the definition. It's a uniform resource locator, so says Wikipedia. It's meant to show you where a resource is and show the internet where a resource is. I think that's really, really limiting, especially in today's world with software as a service, where we're not just getting documents. We're asking a service to do things for us. You know, Twitter's not just a document. You are going and fetching massive amounts of data from specific to you and your feed. What are the different parts of a URL? There's a schema, which is also called a protocol. There's a colon and 2 slashes. Nobody ever forgets those. And then there's a host, also called the domain. Then we have a colon followed by a port number. Nobody ever uses that except us devs. The full path of the resource, quote unquote, and an optional query string, and the fragment identifier, which is everything after the hash mark. So here's an example. I have a bigger example over here. This is not my image. I don't have a reference for it, sorry. So we have the schema. Everybody has seen these things, but maybe you didn't pick apart all the different pieces before. The schema or the protocol up front, that tells everybody what exactly you want and how you want it. The domain, www.google.com. The path, query string, and fragment identifier. So the World Wide Web relies on the schema and the host. Those are built into that. We work on top of those things. We don't really mess with them. We use HTTP or HTTPS or mail or what's the new one? Phone or dial? I don't know. I don't remember. And we don't really mess with those as web programmers. Then we never mess with the colon and 2 slashes. And then we have this third slash here. All the way up to this is the path, the question mark, then a hash mark and a fragment identifier. So the important thing for me is that this line right here, what happens between the third slash and the fragment identifier, the hash mark, is entirely in the server's hands. There's no good, there's no actual defined standard for that. We use a standard. It's called REST. It was defined by Roy C. Fielding in 2000. It's pretty good, but it's not law. And most web frameworks and web programmers have built on top of REST. And it assumes that everything's a resource at a path, just like the file system in your computer. But we can mess with that stuff. So why should we mess with our URLs? Current standards are restrictive. Loading a rich web page to use their tool to retrieve a resource can be ridiculous. For example, if I go to Google Images, but I know that I really just want 400 by 300 animated GIFs, I have to know how to use Google and click through their interface to get to that. There's no programmatic way that I can get that unless I know their API, and then I have to go through all their developer stuff. And the address bar is like everywhere in this world. Third world countries, the proliferation of smartphones is remarkable, and almost everyone on this planet has seen that address bar and has typed into it before. Why shouldn't we mess with the URL? Well, I'll skip to the cons down here. It's confusing. There's best practices in place, like I mentioned, REST, that ease problems about security. And REST had this theory that if we make our URLs nice looking, that people will be able to remember them. That's not really turned out to be the case. Have you ever seen a user type in a full URL with a path to where you want to go? No. Why is now the time? Software as a service. We are doing work already, programmatic work with these URLs, but we're having us, the web devs, write all the code. And it's really easy to mess with this stuff with Rails, Node, Django. It was much harder with the LAMP stack. But whatever. Oh, that's my sweet GIF. Everybody's got to have GIFs. All right. So what should we do with that space? I'm just going to go through some ideas really quick. What if we had /Ruby/ and then some actual Ruby code? That looks cool. We could print hello world. I don't know. But it would get really bad really quick when we tried to do some more complex stuff, like actual well-defined Ruby code. The address bar doesn't really support new lines. What if we tried to put Lisp in there? I don't even know what that does, but it looks horrifying. I hope it doesn't make a curse word or something. All right. C-like syntax would be bad. Lisp would be a little bit better because I don't know why. I don't know. Make your own decisions. What about concatenated programming languages? This is what I'm really going to go into much more in depth next week, why I think concatenated languages are the right choice. Show of hands, has anyone ever heard of concatenated languages? Sweet, come next week. They're cool. Can you guess what this does 3, 4 times? What about this? 3, 4 times, 2, 3 plus times. I don't know. I'm going to skip through that. That's for next week. Factor is an example. Factor is a programming language that does this. It's modern. It does really cool stuff. You can do really cool stuff, blah, blah, blah. OK. I'm going to go really quick. What's the time? I have no idea.
Whatever.
Yeah, until you kick me off. Let me make this much bigger.
4 minutes and 30 seconds.
OK, I'm just going to show you a real quick example. So here's in my URL, I have / you can't see it at all, /exec for exec, and then world space hello space. You can see it much easier down here. This is after that / hello underscore space, or sorry, world space hello underscore plus. And this is the product. This is obviously a terrible interface, but this is the result of that. It did a program for us. It did a thing. I'll show you one more example. Here's a form. Here's a form where I can type a word in. And this was built programmatically. I'm going to type a word in like happy. I'm going to run it. And it found a GIF of happiness for us. I don't know which one. They're pretty happy. So that's the dry look next week. Come on next week, and we'll go a little bit more in depth. Thank you.
All right. Lightning speaker number 5. Come forth.
Oh, shit.
Everybody give it up for Chris Keithley.
Do a thing.
Do you need display port?
Yeah.
Yeah. See if we can find that.
Oh, cool.
Display port? It's not up there.
I can literally run upstairs and go get mine out of my bag. Should I do that?
Is it display port to HDMI?
Yeah. Should I do that?
Probably.
Okay.
So many people like to take things.
Yeah. BRB.
All right. I'll stall. Yeah. Let's see. Some world record run up to floor 6, I think, here. We don't have Guinness on site, unfortunately. I mean, yeah, that's right. I don't know, does anybody want to tell a joke or something not too inappropriate? This will live on YouTube forever, so don't forget that. Anybody? No. A humorless bunch, are you? I don't know. But world class right there. Yeah. Speaker conference. That's a good question. Stuart, you want to say some words about the conference real quick here?
So, if you haven't heard, Scenic City Summit, we're trying to revive a conference here in Chattanooga. For those of you that were fortunate enough to attend DebLink, it's going to be on the campus at UTC on Friday, August 12th. It's all day. We're doing something really rad. Instead of going to a conference and having 1,000 sessions to choose from, we're really trying to focus on 2 really good tracks, emerging technologies, and bringing in some fantastic speakers across the country. So hope you guys will attend. www.sceniccitysummit.com. Thanks.
Who else is working on that with you, Stuart? Chris? Brandon? Greg Ostermeyer? Yeah. Brian Livingston. All right, so it's in the hands of some capable folks there. So get your tickets before they sell out. How many spots are there? 300. Okay, and those things are going fast, so you better get on that. All right, we ready? Ready for this? More or less? Get yourself a beverage. Yeah, hydrate. Stay hydrated out there, folks. It's important.
I did just
Don't want to find you out there on the sidewalk in front of the Edney. We got water back there.
Don't joke about that. That actually happened.
Oh,
So
still
insensitive.
joking. All right.
Okay.
Once more, give it up for Chris for that world record run in floor 6.
Cool. So, that's a long run up 3 flights of stairs. All right, cool. Yeah, I'm on 8. So, this is something I've been working on for a while. Yeah, so just wanted to be able to talk about it a little bit. I'm going to go really quick. This was originally like an hour-long talk, so I'm going to go super fast. But anyway, so let's just jump in. Okay, so who's using feature tests right now, like to help run their web apps? Anybody? They're also called acceptance tests or integration tests in some cases. Like Rails came in and changed all the names for these things. It's real fun. But in any case, feature tests, for those of you who don't know, look something like this. We take a form, let's say. We have a form on a web app, and we want to ensure that something actually comes out of this when we use this form. So what we do is we fill in each of these things, and then eventually we click the button. And then we look for some sort of clue that it actually worked, right? We go and we look at the page, and we're like, did this show up? Like, hey, they signed up, that's awesome. And a lot of times this is handled by a QA department or something like that, but a lot of us have been using tools for a while to test this for us. So we get these sort of acceptance criteria. And the good thing is they represent real users, right? They represent how real users use your site. I assume this is what real users using my site look like. And they're a great way to know right before you push, hey, does everything still work? Is everything still looking good? But there's kind of a dark side to these tests. And the biggest reason, and the thing I want to focus on today, is that they are slow. Because if you imagine what you're doing, you're actually starting up a fake browser, and you're driving that browser, and it's going out, and it's doing real things. And that can be really slow. The other problem is that sharding these tests are really hard. Because you typically have to segregate all the work, and then chunk that work onto different boxes, or different seleniums, or whatever it is. And they still all run serially. Why do they run serially? Well, because what happens when 2 users try to hit your app at the same time? They pollute the database, right? And you could end up seeing another user's data during your test. That's obviously not very good. So historically, this has been a problem, but I thought that we could actually fix this. And so I wrote a tool called Wallaby. That is the funniest, like cutest animal in the world. Wallaby is a tool. It's written in Elixir, and it specifically does concurrent feature tests. So we can run all of our tests concurrently. And I'll talk about how we actually do that and keep our database sanitized. So again, if we look at our original example, right, this form, we want to fill this in, we want to test some stuff. Here's how you would write a Wallaby test. Again, this is Elixir code, so if you haven't used Elixir, that's not a big deal. You'll definitely be able to understand this. So we create a test, we say test users can register. And as part of that, we get a session, which is like your interaction with the browser. We then can compose those things, and we can tell that session to go visit the user's new. We find the registration form, and then we can do some stuff. We can fill in full name with something, we can fill an email with something, we can fill in password, and then finally, we can click the register button. And once all of that's done, we can actually assert things about the page. So for instance, we get the text out of a flash message. Excuse me, still catching my breath from the run. That should be like a Pechakucha style talk problem, like run for a mile and then have to give a talk. And then we do an assertion, right? So hopefully you can see all that's kind of at the bottom. But we just assert that the message text matches up with what we want. So this is how you write a test. And for those of you who haven't written Elixir yet, this pipe right here, this little pipe with the open gator mouth sign there, that just means take the previous thing and use that as the first argument of this function. That's all it means. Same thing in like F#, or Elm if you've used Elm. The great thing is you can see up at the top here, we say async is true. That means we can run this test concurrently with every other test. And we do that this way. So Wallaby, when it starts up, forks 4 different Phantom processes, Phantom.js processes. And I'm building this in right now where you'll actually be able to switch between browsers. Right now it's just for Phantom. But Phantom's great because it's headless and we can control it over WebDriver. So the next thing that happens is you want to run a test. So you say, hey, Wallaby, I want to run a test. It goes, OK, cool. Gives you a Phantom, takes one out of the pool, you run the test, and when you're done, it puts the Phantom back in the pool, and it manages that entire worker pool for you. So that's how we actually do different browsers. And the cool thing is, like, if you want to use 2 different users interacting with your page at the same time, maybe communicating over WebSockets, you can do that, and they'll be in their own browser with their own cookies and their own session and everything. The way it works to actually do the sanitization, though, is really cool. So what happens is when Phantom actually talks to our application, let's say you're using something like Phoenix, which is a web framework for Elixir, and that talks to a database driver called Ecto, which is a way to run, execute SQL queries and such in Elixir. What we do as part of this communication, we actually pass up a bunch of metadata. Including who owns any given transaction that's taking place. And fun hack, we actually pass this up in the user agent string in order to encode and decode stuff because we get a lot of room to actually put all this data. And what happens then is that ownership metadata is ripped out of Phoenix in a plug that I helped write. And we then pass that to the database. The database uses nested transactions. So what happens is, if I want to do a thing and then I do some other things and do some other things, that all ends up in a nested transaction. And I know whether or not I have ownership over that transaction. And when we're done, we roll the entire thing back. So because of that, we actually do get serialization on our database communication. And we ensure that we get sanitization over all of our concurrent operations, which is really, really cool. So anyway, if this is interesting to you at all, I have links to this stuff. If you want to come talk to me about it, that's great. You can go check out the code. And if you're interested in getting started with Elixir, I think this is a really good way to sneak it into your organization. So if, it's the same kind of thing about Canopy and the F# crowd. If you want to get your .NET people to use F#, you start using Canopy. I think if you're a Rails shop or Ruby shop, Python shop, something like that, and you want to start taking advantage of some of these things, you can actually go make this work with Active Record. There's some people working on that right now. So. It's cool. I think it's been a really fun project, and I appreciate you guys and gals listening to me talk about it for a little bit. So thank you.
All right, thank you to all of our wonderful Lightning Talk speakers. Again, we'll be back next week to hear more from Reed. Yeah, thank you guys for coming, and we'll see you then. Yeah, give it up. Give it up for yourselves one more time.